Okay, so before we can solve equations, exponential equations that don't have related bases, we have to know what a logarithm is. Okay, so that's what this tutorial is aimed at. It's very open-ended at the beginning, investigate what it does. Probably some of you tried numbers and got a bunch of decimals, but then eventually you stumbled onto, you picked numbers, say for this, like 1, 10, 100, and so on. Eventually you got to that and you found that the logarithm of those numbers was 0, 1, 2, 3, except I need another 0 there, and so on, right? And that might help you understand what that is. So your first description of what a logarithm is might be how many zeros the number has. Right? That's probably the first stretch. But then you have to be able to explain why you get numbers like you do for these numbers, right? I as much as I've been teaching this course for a long time, I have not memorized what the logarithm of 50 is. But I can at least tell you what it's going to start with, because I'm going to tell you it's going to be 1 point something, right? Because it's going to be between those two numbers. It's not going to be 1.5. It's going to be 1 point something. Just the same way as you could do that with square roots. When you first learned about square roots, just think about what, if you're asked to figure that out. If somebody asked you what's the square root of 31, again, you probably don't know that off the top of your head, but you could at least tell me what two whole numbers it's between. What two whole numbers is square root of 31 between? Yeah, like, so you're thinking in your head 25, 36. So this is going to be between 5 and 6, right? 31's between those two. So square root of 31's got to be between 5 and 6. It's the same thing here. If you know that logarithm of 10 is 1, logarithm of 100 is 2, you know that this is going to be 1 point something or other. So on your calculator, if you were to say the logarithm of 50, you get this number. Let's start with some of the numbers you know there. Logarithm of 100 is 2, because 10 to the power of 2 is 100. Maybe this would help if we got the fancy calculator out too with the, not that, this. Oh, what's happening now? There, okay. Here's the fancy calculator. Logarithm, except the buttons are harder to push. Logarithm of 100 is 2, because 10 to the power of 2 gives you 100, right? Those two things are inverses. The logarithm key is the inverse of this, of the, what would you call this key? You see above, see this says logarithm, but what would you call this key right here? It says 10 to the power of x. 10 to the power of x key, if you had to describe what that does, it takes whatever number you put in and it does 10 to the power of that number. That's kind of complicated, right? Since it's the inverse of the logarithm key, this is actually something people are going to call the anti-logarithm key, 10 to the power of x. Those are inverses of each other, just like any other pair of things, like dividing and multiplying. Right? If I started with some number, like I started with 100 here, I pushed the logarithm key, I got something, and then I used that other key and it undid it and gave me 100 back. If I started with 100 and I did the operation of adding 3, I'm not trying to insult your intelligence here, especially since this is not working, plus 3, okay? I'm not trying to insult your intelligence, but if I took a number, added 3, did the inverse of adding 3, which is subtracting 3, I get the number I started with, right? If I took my original 100 and said, I am going to divide it by 4, and then I take my answer and I multiply it by 4, I get that, right? Those things are inverses. Even these other ones, if you start with a number like 49, and you do the square root of that, square root of that number gives me 7. If I take that number now and square it, I get my original number back. Those are inverses. These are inverses. If I take any number you want here, 78, if I do the logarithm of that number, come on, and now if I go 10 to the power of all that, right? Painfully going to enter everything by myself here. 6, 0, 3. What's it going to give me? 78, the original number. Now, it's rounded this. This is not an exact number. It's like pi. The logarithm of numbers that aren't whole numbers go on forever. They're irrational numbers. So it's giving me approximately 78 because I've rounded it off when I put it in like that. All right? Those two things are inverses. Just the same way squaring and square rooting are inverses or any other pair of things you know. Sine and sine inverse, they're two functions that are opposites. All right? If you're asking for the logarithm of something, when I ask the calculator, what is the logarithm of 78? It's giving me the number that you have to raise 10 to get that number. If you ask for the logarithm of 78, it's basically what exponent of 10 do you need? What power of 10 is it? The logarithm of a number is what power of 10 is it? Even if it's not a whole number, right? So if you go back to some of the numbers we had here, when you ask for what the logarithm is, this number here, you're asking what power of 10 is it? Even if we put that number like 78 would go in here somewhere, right? 78 was in there. 78. What was it again? 1 point something? Was it 1.89 roughly? We'll put approximately that. The logarithm of 78 is that because that's what power of 10 it is roughly. 1.89 like that. So I think if I said what you think how it works. At some point here, maybe down in the box down here, the logarithm of a number. I guess I could say is what power of 10 it is. Okay, it is the exponent you need on 10 to give yourself that number, right? We could make this explanation really mathematical and put in symbols and all that, but I think it helps to put something down simple for yourself. Put a simple example down there for yourself. Maybe not. I mean, you could do one that says logarithm of 1,000 is 3, since what's the equivalent statement with using exponents instead of logarithms? What's the equivalent statement to this? What I mean by that is, like, say somebody said that 5 minus 2 is 3. I'm not trying to insult your intelligence, but somebody's writing it using subtraction. How could you write an equivalent statement with addition? You could say 5 is 3 plus 2, right? Those say the same thing. Those are showing the relationship between those numbers just using a different operation. Log of 1,000 is 3 is the same as 10 to the power of 3 is 1,000. That's why, right? Because it's this. The logarithm of a number is the exponent. If you want one that's not so nice here, logarithm of whatever. Pick a number you want here that's not a nice power of 10. Write down its logarithm. And then write the equivalent statement with an exponential type expression. Can you do that right now? I'm going to pause this. Actually, I'm going to stop this and we can restart again.